Hi, and welcome back to 5-Minute Chemistry with Always Eclectic Stacy. We're so excited to have you here. We're in our covalent bonding series talking about molecular geometry. This is the 13th example of using that with VSEPR and Lewis structures. Let's go. Hi, and welcome back to Always Eclectic Chemistry. These are the 5-minute chemistry videos. We're working with VSEPR and Lewis structures today to help you make sense of some molecular geometry. This is example 13, and we're looking at SO₄². So you already can tell that it's a negative or has additional electrons covalent. So this is our sulfate ions. This is always good to know. And when you see often ions, we know that they are not going to follow the rules of proper bonding. Especially with sulfur and oxygen, it's going to have an expanded octet. The 2 negative means that all of them are going to be filled and that they are all going to be happy. But how that works is going to be really specific. So let's first do our first step thing, which is go ahead and look at our polarity. Sulfur is more nonpolar or less electronegativity than oxygen, so we're going to put oxygen on top. Oxygen has a electronegativity of 3.5. And if you're wondering where I'm getting these numbers, I've referenced the periodic table of electronegativity, and that would be a good thing for you to go ahead and look up if you don't have one already. Sulfur has an electronegativity of 2.5. So if you subtract them, that leaves us with a 1.0 difference, which does make this polar. But I'm hesitant to name this straight off the bat polar because we have 4 oxygens. We know we're going to have an expanded octet. We know we're getting additional electrons. So there may not be a dipole moment based on the molecular geometry. So we're going to hold off on this. This is what this says. But because non um, it's non-standard, meaning it's not sulfur dioxide where there would be a dipole moment. There's 4 oxygens, there's 2 additional electrons. We want to check with the molecular geometry that it maintains a polarity. So remember, the first thing we do is going to go ahead and draw our Lewis dots just so we can see where they might bond. With sulfur, we know that this will not necessarily hold true because sulfur does enjoy an expanded octet. So with sulfur, we're going to go left, right, up, down, left, right, because sulfur is in the 16th column, which means it has 6 valence electrons. Oxygen also is in the 16th column with 6 valence electrons. So it's going to be right, left, up, down, right, left. So looking at these two, it should be pretty straightforward. This can bond twice, this can bond twice. So it should be really straightforward. It should be sulfur monoxide, boom, done. But sulfur is bonding with 4 oxygens, and we have 2 additional electrons coming in, so we know this is going to look funny. So we're going to go ahead and draw sulfur in the middle because 4 oxygens, 1 sulfur, we know sulfur has to be the central atom. And we're going to go ahead and draw the oxygens around sulfur. Don't forget with these, you do have to draw the negative bracket and go, oh yes, this is 2 negative to show that there are 2 additional electrons coming in somewhere. Now sulfur is going to bond twice with each of these oxygens because 2 there, 2 there, double bond. Oxygen's happy. It's going to take this electron and make a single bond, and this electron and make a single bond. Now, sulfur's happy. It has 2, 4, 6, 8, 10, 12 electrons in the shell. It's very happy. These oxygens aren't happy, so you got to remember to go ahead and put in those extra valence electrons that are on the Lewis dot. So now, I represented that one because it's only a single bond. So this is how it would look just normally if we didn't have two extra electrons. But we do have two extra electrons. So you simply put one extra here and one extra here. And now it's very happy. Everything has 8 valence electrons. It's like sulfur that has a ton more because sulfur is a greedy gulch. Now, this is supposed to be polar, but look, all the all the oxygens are kind of spread out equally around sulfur, so there's not a chance for it to have that dipole moment. Plus, with the addition of 2 extra electrons, it kind of cancels out the need to hold more because it's holding those. So this is actually going to be considered nonpolar. I know there's a lot of exceptions in chemistry and it can be difficult. Now we're going to go ahead and look at the shape very quickly. We're going to have sulfur as our central atom and has 1, 2, 3, 4, 5. We have 6 bonding pairs. We have no lone pairs. So this is going to go ahead and be an octahedral. So it's nonpolar octahedral, although it looks like it should be polar because of the extra oxygens and the shape. It does equal out and become nonpolar. This was for the sulfate ion for VSEPR and Lewis structures, looking at how they affect molecular geometry. Thank you so much for following my video. If you like this content, please don't forget to like and subscribe and follow us. Have a great day.